Hey guys, welcome back. In this video here, what we're going to do is we're going to look at another way of possibly protecting yourself from the Wi-Fi in your home. Now, in this particular video here, we're going to look at one specific product that's out there. It's actually what's called a router guard. And this has really been quite a hot topic for me with a lot of the clients that I'm seeing out in the field because they're asking me about this specifically. And they want to know if this product actually does it do anything? Does it actually work? Does it block any of the radiation that's coming off your router? And is there actually a way to test to see if this thing is indeed working? So that's kind of why I wanted to shoot this video here, because I've bought a number of these different router guards and I've been kind of testing them for the last several months. And this video, I just want to show you guys some of the results that I've got. And I'm hoping this will kind of help you guys decide whether or not you actually want to go ahead and purchase one of these. And I want to give you guys all the information that you need to know before you actually go ahead and do that. Now, I posted an article down here on the bottom right of the screen. You can see here, it's from a doctor named Dr. Diedrich Klinghardt. And I posted this very same article in the previous video that I did, but this is really worth stating again, because in this particular article, he's saying that 50 years ago, we knew that this 2.4 gigahertz frequency that's used in Wi-Fi is the wavelength or the frequency that actually destroys the ability to fight off infections. So what this is telling us is that really this particular frequency that we're using in Wi-Fi, it has the ability to impair our immune systems. And we knew this 50 years ago. And now this is the 2.4 gigahertz frequency. It's really one of the most popular frequencies that's used around the planet. So if this is the case, and most of my clients that I'm seeing out there too, they're really hesitant to completely get rid of their Wi-Fi. They don't want to completely turn it off. And they're constantly asking me about, is there a safe way to use Wi-Fi? Like, what can we do to use it safely? So that's kind of why I'm doing this video series here, to kind of show you guys really what's out there and what the possibilities are. But just so that you guys know, I don't actually use Wi-Fi in my own home. I don't recommend my clients use the Wi-Fi at all, if at all possible. And Jesse and I we've gone hardwired. So I have everything actually wired into all my devices, and I keep the wireless turned off. Now, there's specific times where I may need to turn on the Wi-Fi, like if I need to kind of go into maybe a Zoom meeting or something like that, or if I'm doing something in the backyard, I may turn it on just for a short period of time. But almost all the time, it's shut off. I've got this thing kind of permanently disabled so that the wireless doesn't even emit anything. Now, before we actually get into all the testing here, I kind of wanted to just go over how we believe this device actually works. Now, the proper term to actually use here is we shouldn't be calling this thing an actual router guard. The proper term to use is what's called a Faraday cage. Now, some of you guys watching this might be familiar with that term. And if you're not, really what a Faraday cage is it's a device that actually blocks the electromagnetic fields. So you can see here in this image that I've got in the top left corner, you can see we've got our Faraday cage and we've got the router sitting inside of it. So what's going to happen here is that any electromagnetic radiation that's emitting off of this router, which is our Wi-Fi signal, the idea is that the majority of that signal will be contained inside of this cage. Now, it's important to note that we don't want to block 100% of this signal, which means we don't want to contain all of that Wi-Fi signal inside of this cage. That's not the intended purpose of this, because obviously we still need to be able to connect our cell phones. We need to be able to connect our laptops. So some of this signal still needs to make its way out into the environment. So really the idea with this Faraday cage here is that about 90% of that Wi-Fi signal will be contained inside of this cage, which means only 10% of that signal will still be allowed to radiate out into your environment. So really, in theory, by using one of these devices, we might be able to block up to 90% of the intensity of that Wi-Fi signal that's coming off your router. Now, this particular Faraday cage that you see here, if you notice, it's made of a conductive metal material. And the material that kind of surrounds all around the Wi-Fi router here, you can see it's made of a material, really a perforated material that is made with tiny little holes. Now, this is really, really important here because this little detail is really fundamental in how this Faraday cage actually operates. And it really operates on the wavelength of this Wi-Fi signal. Now, what that means is that this Wi-Fi signal that's radiating off your router here, inside your router, there's going to be little antennas inside. So that Wi-Fi signal radiates off those antennas and radiates out into your space. Now, what we actually believe is happening here is that this electromagnetic wave, as it's radiated off into the space, what that electromagnetic signal is doing, it's actually changing its motion as it's traveling through space. And we really describe that change in motion with something that's actually called frequency. So to kind of put that into perspective, this Wi-Fi signal that's radiating off your router, which operates at 2.4 gigahertz. Now, what that means is that electromagnetic signal that's radiating off into your space, it's actually changing its motion 2.4 billion times per second. Now, as that signal goes through one cycle of change, it's believed that that signal is actually traveling a certain wavelength. Now, you can see to the right of your screen here, I've got a little image that kind of shows you the relationship between the wavelength and the frequency. And there's a third variable involved in this too, which is something called the velocity of light. And there's an equation here. And this equation is something that's very, very powerful in science. But the wavelength that corresponds to this 2.4 gigahertz frequency is actually calculated to be 12.49 centimeters. So now what's happening is, as this electromagnetic signal is radiating off your router, and it's cycling or changing its motion 2.4 billion times per second, and as that signal goes through just one change, it's traveling 12.49 centimeters. And again, this is happening 2.4 billion times a second. So it's incredibly fast what's going on here. So really the rule of thumb kind of when designing one of these Faraday cages for a situation like this is that we want to design these little holes here to be about 1/10 of that wavelength size. So we want the holes to be smaller than the actual wavelength of that signal that's traveling through the space. That kind of makes sense because we want to contain most of it. So in the case of this 2.4 gigahertz frequency, that 1/10 of that wavelength will work out to be about 1.5 centimeters. Now, if you look at the little holes here that are in this cage, I measured it. It actually works out to be something like 0.5 centimeter, very, very, very close to it. So what that means is that the majority of that signal will be contained inside. And since there are little holes there, that means some of the signal will still be able to get out into the environment. So it's not going to block 100% of it. Now, there's a few things I just want to kind of bring up to you guys that you should really pay attention to here before you go ahead and buy one of these Faraday cages and install it on top of your Wi-Fi router. And it really has everything to do with the signal coverage that you're going to get inside your home. Because we have to remember, when we install this Faraday cage on top of our Wi-Fi router, that Wi-Fi intensity level, it's going to decrease by up to 80-90% in most cases here. So what that means is It's like, say for example, you put your Wi-Fi router in your basement, and say you live in like a two-story home. Now, say you're trying to get that Wi-Fi signal all the way up to the second floor, and maybe you have a bedroom on the further corner of your house. Now, since this Wi-Fi radiation is going to decrease, the intensity level is going to decrease by about 80–90%. That means by the time that signal gets all the way up to the second floor, it may be in some cases too weak to maintain a stable connection to the internet. And I've seen a lot of people on YouTube kind of reviewing some of these router guards. And this is one thing that they get really frustrated with, is that their internet keeps kind of coming in and out on maybe their cell phone or their laptop. Now, this is something that we really need to pay attention to. And I just wanted to kind of bring up a few key points here that will really ensure that you get the best possible coverage, even with this Wi-Fi router guard. Now, one important thing I just wanted to kind of mention here is that I've installed a few of these now into people who live in an apartment building or even a condo, where it's really just kind of one main floor, and they have just a few bedrooms or maybe even one bedroom, but everything's just on one main floor. So this Wi-Fi signal doesn't have a whole lot of area to cover. Now, in all the installs that I've done, I've never had anybody have any issues with signal coverage as of yet. It's people that actually live in bigger homes, people that might have like a detached home, one that's like 2, maybe even 3 stories. This is something that you guys need to pay attention to so that you don't get frustrated with some of this stuff. And I just want to kind of bring up just a few key points here that will kind of help make your life a little easier when it comes to this. And it has really everything to do with the position of your Wi-Fi router in your home, where you're actually going to put this thing once you put this Faraday cage over top of it. And the first thing is really try and do your best to avoid placing your router around anything made of metal. Because we have to remember, this Faraday cage that you're putting over top of your router, I mean, this is made of metal. This is what's going to contain and kind of block that signal from getting out into the environment. So if, say, for example, you have your router and you put it inside your router guard, and maybe you put your router guard right beside maybe a metal filing cabinet, for example. Now, what that filing cabinet's going to do, it's going to block some of that signal from getting out into the environment. And that's something we don't want to do, because we're already blocking enough of it with this Faraday cage that you're putting over top of it. So really pay attention to that. Make sure there's nothing really made of metal that's anywhere around where you're going to put your router. The other one is really pay attention to mirrors, because, like, say for example, you have your router placed in your office, and right on that wall closest to your router there might be a huge mirror. Now, what that mirror will do is it's really going to reflect that Wi-Fi signal from getting out into the environment. So that's something else to really pay attention to is these mirrors. Now, the other one to consider is the actual flooring that you're using. Like, say, for example, you have your Wi-Fi router maybe on the main floor, but you've also got a second floor, and you're trying to get that Wi-Fi signal upstairs into maybe some of the bedrooms upstairs. But depending on the flooring that you're using, I mean, this could be, you could have some type of tile flooring or some kind of wood or laminate. These types of materials will attenuate this Wi-Fi signal to some degree. Now, one other thing that you guys got to pay attention to as well is concrete walls. Now, if you have a wall that's made of concrete and you have your router placed in a room right next to that concrete wall, and you're trying to get that Wi-Fi signal into a room on the other side of that concrete wall, I mean, this concrete wall is going to really attenuate that Wi-Fi signal even further. I mean, these types of walls do a really good job at kind of blocking some of these signals. But really, the key to this is that really all physical objects will attenuate that Wi-Fi signal to some degree. Now, some materials obviously more than others, like metal, but this is something to kind of pay attention to here. And I've got a kind of image here shown here on the left. You can see they're placing their Wi-Fi router here in the very corner. And you can see where the dead spots would be, and you can see where you're going to get some good Wi-Fi signals, right? I kind of talked about the metal filing cabinets here. Like on the other side, you can see that this spot here is going to be kind of a dead zone. You've got mirrors on this wall where on the other side of that mirror, you're going to have kind of a dead spot as well. So I just wanted to kind of bring this up because, like I said, that Faraday cage that you're putting on top of your router, it's going to dampen down this Wi-Fi signal significantly. And it's going to make it quite weak. And that means it could make it a very unreliable connection for some of your devices. And I don't want you guys to kind of get frustrated with some of that. And just pay attention to some of these things that I just said here. And really the last thing I kind of want to mention here too is that don't put this router next to any people or any of your children for that matter, especially. Like say, for example, you've got your router in maybe your office on the floor. And right on the other side of that wall might be where your child is sleeping. And that could only be like 3, 4, 5 feet away, maybe even less in some cases. Remember from the last video, the closer you get to that Wi-Fi source or that radio signal source, the much more intense it's going to be. Now, I just kind of want to show you guys some of the actual meters that I'm going to be using here to kind of do this job. And really, I'm going to be using 3 different meters. And some of these meters that I've got here, I've got some really decent equipment here to do this type of work. And some of these meters I have are really professional type of meters here. And really what I've got here, as you can see here on the left, I've got just a general EMF meter. And really what this does is it measures the actual power density of that Wi-Fi signal. And these 2 meters kind of shown here on the right hand of your screen, you can see these are actually what are called spectrum analyzers. Now these tools are in my opinion, they're really much more powerful for this type of work. And most of the people really doing a lot of this EMF type of work, like this EMF meter here on the left, this will be the type of meter that they have. And really what this meter does is it looks at quite a large range of frequencies. As you can see here with the specs that I've got here, you can see it's looking at a frequency range of 10 megahertz all the way up to 8 gigahertz. So it's really quite a large window that this meter is kind of looking at. And really what it's going to do is it's going to show you a number. And that number is measured in what's called the power density. So this meter here really, for me, is really only good for kind of telling you if there's something there. This meter won't be able to tell you exactly what is there and where it's coming from, because it's looking at such a large range of frequencies. But it is good for telling you that, okay, there's something here, there's something present that we need to pay attention to. But it's these 2 spectrum analyzers here on the right-hand side. These are the tools that really get you to kind of dial in to very specific frequencies and a very specific kind of range of frequencies that you want to look at. And you can get a lot more data from them. And you're going to see what I mean by that once I kind of show you some of the results here. You're going to see the differences between all these meters. But when it comes to really analyzing our Wi-Fi router with this Faraday cage over top of it, this meter here, this general EMF meter here on the left-hand side, we're going to see that it's not really an adequate meter for this type of test. And really, once we get kind of going into some of the testing, I'm gonna kind of show you guys why. Now, the actual test environment that I'm going to be using to do this test, I'm doing this actually in my own home. And I live in a 2-story home with a basement. So really, I actually have 3 different floors here. And I will be placing my router right on the main floor, right between the 2nd floor and the basement. I've got a place there right behind my TV unit. And you can see that's kind of depicted here in this image to your left there. There's my router. It is kind of behind my TV unit, which is really almost in the center of my house. And I will be running the 2.4 gigahertz frequency only for this test. That's the only frequency I'm going to be running. And I've pre-configured my router. It's actually running on channel 1, which actually works out to be 2.412 gigahertz. Now, there is a video that I'm working on that kind of shows you a little bit more detail into really understanding the technology of Wi-Fi. because there's a lot we need to know here, because there's a number of different channels that Wi-Fi works on. And that's just important to know. I'm not going to touch any more on that in this video here, but I have pre-configured my router to run on channel 1. And really all of the other wireless signals in my home are off. Like all my cell phones, they're turned off. All Bluetooth devices, anything else that I could find within my own home, everything is completely off for this specific test. Now I will be running 2 different tests. I'm going to run 2 different tests in 2 different rooms of my house, so you guys can get a feel for what this Faraday cage is really going to do. And in both rooms, I'm going to test without the router guard, and then I'm going to do another test with the router guard. So you can kind of see the before and the after in each of the 2 rooms that I'm going to be doing in my own home. Now, the first test I'm going to be doing is actually in my own living room. And I've got an image here in the center of the screen kind of showing you my my living room, my TV unit more specifically. And really, if we kind of look right behind this section here that I'm circling, this is actually where my Wi-Fi router will be. It's going to be behind this this TV unit here. And I need to do that in my home because this Wi-Fi router guard doesn't look very pretty. And Jesse tells me that I really have to keep this thing hidden. So that's why it's kind of behind that TV unit. And if you notice here in this left-hand corner, you can see there's a little meter symbol. This is actually my couch here. Now this is actually where I spend a significant amount of time. I've got a special connection that I've made behind my couch there, so I can actually hardwire my laptop in to the internet, and I can do all my work on my laptop. So I kind of figured that this would be a really good test to do. And really, when I'm sitting on this couch, I am about 10 to 12 feet away from the Wi-Fi router. Now, the second test that I'm going to do is actually upstairs on the 2nd floor. Now, this is actually Jessie's office, and this is where she spends a significant amount of her time as well. And my office there, if we look at this center image here, if we were to kind of go up these stairs here and go all the way up, my office would be kind of over here in this corner somewhere. And really where Jessie's kind of desk is situated, it really works out to be about 20 feet away from where my router will be. So these are the 2 hotspots that I've kind of picked in my house to kind of do these tests. So let's take a look at some actual measurement results here with this particular Faraday cage that I have in my home. And the very first test that I'm doing, like I just mentioned, I'm going to be doing it on my main floor living room. And I'm going to be doing this first test with no router guard or no Faraday cage installed. So I'm basically running my Wi-Fi as normal. And I'm going to be running this 2.4 gigahertz frequency at channel 1 on my router. And I'm going to be putting my meters on my couch, which works out to be about 10 to 12 feet away from the actual router. Now I'm saying 10 to 12 feet away because if you imagine that I'm actually sitting on the couch, that Wi-Fi radiation, the way it actually would hit my head or the way it would hit my chest, I mean, there's a difference in distance compared to where that radiation would be hitting my legs, for example, or my feet. It's just the way that I'm sitting. It works out to be there's a distance difference, obviously. So what I'm doing is I'm trying to place my meters kind of in the center general area of where I would be sitting on the couch. So the first measurement that I've got here is from just my general EMF meter. And this particular EMF meter, it actually measures the power density of that Wi-Fi signal. And the unit of measurement that we're using here is what's called microwatt per meter squared. Now you can see with this meter here that I got shown here on the bottom left of your screen, you can see it's got a value on the screen and it's holding. So what this value is actually showing you, it's actually showing you the maximum Wi-Fi intensity level that I'm measuring in that particular area that my body would be exposed to. This is essentially what I'm kind of showing you on the screen here. Now, if we look at this particular value, what this works out to be, it actually works out to be 2,105 microwatts per meter squared. Now I'm kind of showing you right above it the actual target here. Now, this is actually the target that's actually pulled from the building biologist guidelines. And it's showing you that it needs to be less than 10 microwatts per meter squared. Now, this would just kind of put you in a mild kind of risk factor here. So this is kind of the target that I would like to see people try and aim for, but you can see what I'm measuring here. This is 2,105 microwatts per meter squared, and the target is 10. So clearly, this is a lot more than what we want here. So we need some type of remediation involved here. Now, just to give you kind of a brief description of kind of what this means, this power density microwatts per meter squared, what this means is that I kind of got an image kind of shown here in the top left of your screen. And right here, I'm kind of circling here. This is kind of just showing you an antenna. Now, this antenna is radiating out a signal. So just imagine this antenna would be your Wi-Fi router. This is what's emitting that Wi-Fi signal into your space. So what we have here is actually two kind of blue squares. What this is actually showing you is this is actually the measurement point. This is the point where I would be putting my meter to measure that radiation intensity. So what's really happening here is as I'm putting my meter in that space, what the meter is actually doing is it's measuring the amount of electromagnetic radiation that's kind of passing through a particular window. In this case, it's actually a meter squared window. So it's really what this meter is it's kind of scanning a whole bunch of frequencies. And it's actually measuring the amount of power density that's kind of passing through that window. So this meter has a whole bunch of different kind of tuning circuits inside of it, so it's able to tune into all kinds of different frequencies. Whereas this particular meter here, it actually operates between 10 megahertz and 8 gigahertz. So it's a huge frequency range here with this particular meter. But really the advantage of this meter, which makes it, a little bit more advanced than most meters that you would find, like a tri-field meter or some of the other basic type of meters that you can find out there, is that I have the ability to actually calibrate this meter to tune into a specific frequency. So what I've done with this meter is I actually calibrated it to tune into the 2.4 gigahertz kind of span here. So it's really looking at that particular window of frequencies. So this meter is just really measuring the amount of electric power density that's kind of passing through a window at that particular frequency. So that's kind of really how this meter works. Now, the second meter that I'm showing you here is my spectrum analyzer. So this meter here is a little bit more advanced than the meter on the left. Now, why? I have down here at the bottom, you can see I've got a little orange arrow. And this orange arrow is kind of pointing to 2.411 gigahertz. Now, if you remember from earlier, I told you I'm tuning my router to run on channel 1. So with this spectrum analyzer, I can actually tune in and look at that specific frequency here and see what's going on. So that's really makes this meter much more powerful than the meter on the left, because the meter on the left is just scanning that frequency. And we don't know truly kind of where it's coming from. We don't know, maybe it could be your neighbor's Wi-Fi, it could be, maybe a Bluetooth device or, something like that. We don't know specifically with this meter what's going on. Whereas a spectrum analyzer, I know for certain that I'm tuning into my router. So that's really the key that I wanted to kind of bring up here. But this meter here is just really measuring the amount of electric power that's available. And the units that it's using it's using decibels. So when we're dealing with decibels, we're dealing with an actual ratio. So to give you a basic idea of kind of how this works, this dBm unit of measure here that I'm using, it's really measuring the absolute power that's kind of delivered into a resistive type of circuit. Now, since we're dealing with dB and since we're dealing with, this is obviously dealing with a ratio, the ratio itself is reference to a common reference point. So I'm actually showing you this with this red kind of arrow here. The reference point that we're using here in this particular measurement is 0. It's 0 dB. So it's kind of measuring what's going on in the environment as it's comparing to this 0 kind of reference frame here. And this 0 reference frame, it's interesting because it's not truly 0. Because what we're dealing with, if you look at this chart here, we're dealing with power in milliwatts. So we're dealing with 1 milliwatt of power. So what we're doing on this reference frame is that we're putting a signal into a resistive circuit, and we're kind of measuring the power dissipated from that particular event. And then what we're doing is we're actually measuring the environment and kind of comparing to that reference point, that 0 decibel reference point. And we're trying to figure out if we're above it on the plus side or if we're below it on the negative side. So that's kind of really what's going on here. And that's really the key difference between just a general EMF meter, where it's kind of measuring the amount of power kind of passing through a window specifically, whereas a spectrum analyzer is just kind of measuring the amount of electric power referenced to this very common reference point. So in the communications world, this is a very standardized method of testing here with this particular dBm measurement. So I just wanted to kind of quickly just cover that so you guys get a basis of kind of what's going on here. But since we're dealing with dBm, what we can do is we can actually convert that. We can convert this over to an electric power unit. And I've already done that. You can kind of see here in brackets here. This negative 28 dB measurement that I'm measuring here with my Wi-Fi on works out to be about 1.585 microwatts of power. And that's the amount of power that's kind of available in that space where my body is. So if we have a look at the other 2 meters that I've got here, you can show I've got kind of 2 different screenshots here. And I kind of wanted to show you guys the first screenshot here is because what I'm showing you here is the actual Wi-Fi channel that I'm tuning into. And you can see it here kind of shown between this orange arrow and this blue arrow. This is kind of the frequency span of that channel, which works out to be about 20 megahertz. Now I'm going to dedicate a video coming up here specifically so you guys can kind of see what's going on here, because it's going to be so important to kind of see, because you can see that there's a lot of activity going on this Wi-Fi channel. So as you go kind of upwards, this is just kind of showing you the intensity level of that specific frequency. And the frequency span here is kind of showing you on the bottom here. This is the channel frequency span that I'm kind of tuning into. So you can see there's a lot of activity going on here. And in a future video, I'm going to kind of tune right into that and kind of show you what's going on inside this, because I think you guys want to see this. So I just kind of wanted to kind of show you that first, but the meter here on the right is actually showing you the specific measurement that I'm taking here at this 2.412 gigahertz frequency. So what I've got shown here is I'm kind of showing you the maximum kind of intensity level of that signal that my body would be exposed to. And it's kind of shown here by this orange arrow. And this orange arrow, as you can see, it works out to be about negative 31.2 dBm. This is the decibels. Again, we're dealing with just electric power, the peak amount of electric power here. So if we convert that over, you can see what we're dealing with is about 0.759 microwatts. So there is a little bit of a difference between these 2 spectrum analyzers, as you see, because I'm measuring negative 31.2 and I'm measuring negative 28 on the other one, which is, I mean, it's very close, but there are some differences, and the differences really have to do a lot with the antenna that I'm using. The antenna makes a massive difference in your dBm measurements here, and all these things need to be kind of taken into consideration here. So there are some differences, and that's really one of the core reasons why, but I really wanted to kind of show you 3 different measurement tools kind of measuring the same thing here. So you can kind of, we got 3 ways to kind of look at the results here. Now, just one side note here before we continue, I think this is something really, really important that I kind of wanted to just bring into your awareness here, is that the actual method to how these 3 meters here are measuring the electromagnetic radiation in the environment, it may not, I'm going to emphasize the not, be the same method to how the human body senses this electromagnetic radiation. This is what I'm seeing. I'm just giving you my personal opinion on this, and I hope future videos will kind of set this up to kind of go to my train of thought here. But this is something that I see here, is that these instruments might be sensing this Wi-Fi signal, whereas our body may not be sensing it the same way. And if what I'm saying is any accuracy to it, this is massive, because I mean we're setting standards here in all over the world for the levels of electromagnetic radiation that's safe for us. And if we're developing these standards based on our scientific knowledge that may be rooted in basically not the fundamental truth of things, is kind of where I'm going to. And I just wanted to pop that into your awareness because it's important. It's going to be important as these videos go to kind of come back to this point. So now what we're going to do is we're going to do this exact same test. And what I've done is I've gone over is I've put this Faraday cage on top of the router. My meters are in the exact same place. I didn't move them. But that's pretty much the only difference, is now we have the Faraday cage in place. So let's go ahead and see what we've got this time around. So with my EMF meter here, as you can see, I'm kind of tuning into the 2.4 gigahertz frequency, and you can see the number that's holding here is 256.5 microwatts per meter squared. So what this works out to be compared to the first test that we did, what we've got here is about an 87.8% reduction just by putting that Wi-Fi cage in place, which is pretty significant, I think, here. But I'll also note here that the actual target that we wanted to get to, which just really puts us in the minimal type of risk situation, is that 10 microwatts. So we're not quite there, but we've gotten significantly closer. Now, the second measurement that I've got here with my spectrum analyzer, as you can see, now I'm measuring negative 37 dBm. So this is kind of the peak level, which works out to be about 0.1995 microwatts, which is quite small. But what this works out to be is that this is actually about an 87.4% reduction just by putting that cage on top. So if we go to my last meter here, you can see what I'm measuring, and with this one is that it's showing us negative 40.7 dBm. And that's kind of what this yellow line is kind of showing you, the highest kind of peak value on that Wi-Fi channel. You kind of see it kind of shown here on in yellow here. And that works out to be about 0.0851 microwatts. So it's quite small. And what we're seeing here is an 88.7% reduction. So you can see between the 3 meters here, all doing kind of the same idea, even with the EMF meter, it's right around 88% reduction. Now, before I leave this screen here, I kind of want to just go, direct your attention to the top left here. You can see this is something that's called the Wi-Fi reliability. Now, in order for your Wi-Fi to be reliable, and in order for your devices to maintain a reliable connection, maintain your data speeds uninterrupted, all these things are important to you. You can see here we've got a little kind of standardized chart here, whereas if we're dealing with this dBm scale, you can see a perfect signal would kind of be described as negative 30 dBm. This is where you're really not going to have any problems whatsoever with your Wi-Fi. And if we look at the measurements that we've got here, you can see we're dealing with about negative 37 and negative 40. So if we compare that to this chart here, you can see we're right between this negative 30 and negative 50 dBm kind of measurement, where we're looking at a perfect and an excellent signal. I mean, they kind of classify a difference there, but really what we've got here with this router guard, as you're sitting only 10 to 12 feet away, you're still going to get a great signal. You shouldn't have any interruptions whatsoever. And that's been my experience with it. I've never had any interruptions with my Wi-Fi as I've been testing this in the entire time I've been testing it. So this is important for you guys to kind of note as well. But what's also important to note here is that you can see there's a negative 67 dBm. This is really the point here to where this is the bare minimum to kind of maintain a reliable internet connection and still get good quality kind of voice and video kind of features here. This is really the standardized point here that we need to pay attention to, because if we cross below that point, this is where we could really have some disruptions that could really become a nuisance to you. So now let's jump right into test number 2 here. Let's go upstairs into my office, where this is where Jessie does all of her work, and really where she spends most of her time. And this might be one for you guys to kind of really pay attention to this test, because it may be simulating an environment very similar to yours. So this first test, what I'm going to do is I'm not going to use the router guard at all. I'm just going to run the Wi-Fi as normal. And I'm going to be placing my meters pretty much right around her desk there where she sits. This is kind of where I got my meters set up. And it works out to be about 20 feet or so away from the Wi-Fi router. But what's also important with this test is that I have my router on the main floor, so this Wi-Fi signal has to come up through the flooring here to go upstairs, and it has to pass through a couple different walls to get into that office space. So there are some obstacles in place here, which are going to be important here. You can see the first test that I got here with no router guard at all. What I'm measuring here with my EMF meter is 131.5 microwatts. So you can see a significant change here in the Wi-Fi intensity compared to where I was in my living room. So it kind of shows you that a lot of these obstacles in these walls, they do reduce the intensity of that signal significantly, especially if it has to go through many different physical objects. And I'm kind of showing you the target here, which is 10 microwatts per meter squared, which is kind of a slight risk. This is where we want to go. And we're just a little bit higher than that with no router guard installed yet. So my second meter here, this is my spectrum analyzer. What it's showing is negative 52 dBm. This is kind of the peak measurement. Again, I've got this little orange arrow kind of showing you that I'm kind of tuning into the actual Wi-Fi 1 channel here, or the channel number 1. And this works out to be about 0.0063 microwatts. So we're dealing with a very weak signal here, a much, much weaker signal. Now here's my last meter kind of showing you here the results. I've got this little orange arrow here kind of showing you the highest peak kind of values that we would be exposed to in this area. And it works out to be about negative 55.6 dBm, which works out to be about 0.0027 microwatts. So again, we're very close. The spectrum analyzers are very close to each other. Again, differences in antennas and some other variables here, which is why they're not exactly the same. So key to remember that. And if we look at this little Wi-Fi reliability chart here in the top left, you can see the negative 52, the negative 55, kind of puts us in between excellent and reliable. Now let's look at the second test here. All I've done differently with this test is I went downstairs and I put that Faraday cage back on top of the router. All the other variables are the same. Meters are in the same place. Let's take a look and see what we've got this time. So with my EMF meter, what I'm measuring is 69 microwatts per meter squared. So this is only a 47.5% reduction. Now, I'm going to come back to this measurement in a minute, because we're now beginning to see the kind of the limitations of using a meter like this for this type of test. Now, my first spectrum analyzer here, you can see what I'm measuring now with the router guard installed, negative 61 dBm. That's kind of the peak measurement. You can see I got my little orange arrow here, kind of tuning into that specific Wi-Fi channel 1 that I'm working with here. And this works out to be about 87.4% reduction. Again, kind of very similar to the first test that I did. The reduction percentages are very much the same here. Now here's my second spectrum analyzer. As you can see, I'm measuring negative 64.6 dBm. I'm kind of showing you here the orange kind of arrow, kind of tuning into the highest peak of that Wi-Fi channel that kind of spans 20 megahertz. And the reduction that we're seeing here works out to be about 86.5%. So again, the spectrum analyzers seem to be kind of very much in tune with each other, and it's between 85 and 90% reduction that we're seeing in just about all the areas. Now, here's where things get a little interesting here, because there's two things I want to kind of bring up here. And the first one has to do with this EMF meter here, the results that we got this time around in test number 2. You can see we only got a 47.5% reduction. And all the other meters were consistent with, maintaining about 85 to 90%. So what happened here? And after further analysis here, I figured out that where I'm taking these measurements in the upstairs office, I'm very much closer to my neighbors. Actually, my neighbor is very close to where I was measuring. So the level of intensity is a little bit higher than what it would normally be because I'm kind of measuring a combination of the signal that's coming from my router and my neighbors. But the bad thing is that this meter doesn't know how to distinguish between that. It doesn't know how to distinguish between my neighbor's router and my router. It's just it's analyzing all of it. It's just picking up all the signals between that, within that 2.4 gigahertz range, and that's all it's doing and showing you a number. Whereas these two spectrum analyzers, I can tune in directly to my router. So that's the difference, and you're kind of seeing it kind of playing out here. And I just wanted to kind of mention that. So that's the first thing. The second thing is, if we go to this Wi-Fi reliability chart up here in the left-hand corner, you can see the measurements that I'm getting here with my two spectrum analyzers, negative 61 dBm and negative 64.6. This puts us at the reliable, like moving more towards the minimum for voice and data. So we're getting very close to this negative 67 dB kind of. It's a very important measurement here in Wi-Fi reliability. But what I have found, as I've been in my office upstairs, and Jesse has as well, is that we've noticed some disturbances to the Wi-Fi. The reliability is a bit of an issue now, considering that we're so far away. We're about 20 feet away, and the fact that the intensity levels of the Wi-Fi is now so weak with this router guard in place. It's got to move through different walls and flooring and all this other stuff. So we've got some issues now. And this is something I just really wanted to kind of bring to your attention, because this is something that could happen to you if you live in a bigger home, especially a multi-floor home. And again, going back to the earlier points of this video, the position of your router is really going to be key here. And there really could be some trial and error involved in this if you guys want to use one of these Faraday cages, because you may notice that your reliability of the internet may drop out at certain points of your home. So that pretty much concludes all of the actual testing that I did. So really, what can we actually conclude from all this? What can we take away from all this data that I'm showing you here? Because I'm kind of throwing a lot of numbers out at you, and I'm showing you the reduction levels that you can see if you actually purchase one of these router guards. And really the first point that I kind of want to bring up here is that even with this router guard installed, the Wi-Fi intensity levels never truly get into the safe levels, according to the building biologist. And this is important, because even though we're getting about 87, 88% reduction levels with this router guard, we're still not quite there yet. And this is important to know. And I'm kind of showing you the building biologist kind of guidelines here. This is for like the sleeping areas or for major common areas where you spend a lot of your time. And you can see that this row here that I'm highlighting here with this black arrow, it's showing you the section for the high frequency. This is all the wireless stuff. So this is all your cell phone radiation. This is all your Wi-Fi, your Bluetooth, all that stuff falls under this category. And you can see the units of measure here I'm circling. It's microwatts per meter squared. And really, to be in a no concern situation, they're calling for less than 0.1 microwatts per meter squared. Now, to me, that's something that's almost next to impossible to really achieve if you live in the city or some type of dense area. It's very challenging to get there. So please believe me, it's really hard to do that unless you're living out in the middle of nowhere. That's why realistically, I kind of aim for anything less than 10, ideally, and even that is very challenging to get to. But you can see on the right-hand side, we've got the extreme range where anything over 1,000 microwatts per meter squared here. So this is kind of what the guidelines are. And with this router guard in place, with the situation that I have here in my house, I never truly get to a safe level, even with the guard. So that's the first point I wanted to kind of bring up. And with my spectrum analyzer that I've shown you, these are the more accurate tools that I've used in this test. They're showing about an 85 to 90% reduction in EMF intensity, which is significant, very, very significant. We should not, overlook that, even though we don't get to the kind of the safer levels that we need to get to here. So personally, in a situation like this, what I would recommend to my clients, I would recommend going to a wired network. I mean, this would reduce that EMF risk much, much further. I mean, we just don't have the Wi-Fi intensity at all because the Wi-Fi is not running. So this is one thing that I would kind of recommend to people, that if this is really a concern for them. Now, really, the placement of your router is really the key here. And in the test that I did, I placed it about 10 to 12 feet away from me, where I'm doing a lot of my work on the couch. And with the router guard installed, I was measuring about just over 200 microwatts per meter squared. So if we look at this chart here, 200 microwatts, this would be between 10 and 1,000. So this would still kind of put us in a more severe situation. But since we're seeing about 85 to 90% reduction, we have to remember that before this router guard was installed, we were in an extreme situation. And we dropped ourselves down a level just by doing this. And we should not overlook this, because I think this is significant, because we got to remember, this is something that, works with time. It's the amount of this radiation that we're exposed to over long periods of time, like when we're sleeping or like when we're in the office working away. So this is something that I just wanted to kind of pinpoint here. Even though it's not to the level that we would like to see, it is significant. And if we come back to this study that we kind of showed in the previous video that I did, Magda Havas did an article on this particular study, and it was done for the US Army back in 1974. And really it dealt with this 2.4 gigahertz frequency used in Wi-Fi, and it's been linked to really one of the most lethal microwave frequencies that we could be using. And really the conclusion of this study kind of suggests to us is that the higher the Wi-Fi intensity, the quicker the rats in this study died. So we're dealing with a level of intensity here. When we start to raise the intensity, we're kind of speeding up really the process of, killing off these rats. And I think this is really an important feature to cover, because this is kind of what we've done with this particular router guard, is we've really drastically reduced the intensity. And like I said, it may not be in the safe areas according to the building biologist guidelines. I really truly believe that this really could be worth our while here to really attempt this in our own homes. Now, in this particular study here, if you kind of look down at the bottom here, I've got a section of it highlighted in blue. The power levels that they used in this study was significantly higher than anything that we're measuring here with the Wi-Fi. So it's important to note here, but those high levels of intensity that they used in this study, they only did it for just a few seconds. As you can see down here at the bottom, from 300 to about 8 seconds, they were kind of just exposing these rats in different intervals at these specific intensity levels. So we are much, much lower. So that is something to consider here. And according to most scientists out there, they're saying that this level of electromagnetic radiation at this low intensity that I'm measuring here poses no threat. If you guys do consider this option, if you do consider buying one of these Faraday cages, I would also suggest to combine it with a mechanical timer, which I've already done a video on this. When we combine the two together, this becomes something quite powerful for you guys to do. That's actually very simple for anybody to implement. I mean, I've already shown you, some of the timers that you can buy. I've showed you kind of how to set it up, how to plug your router into it. And now I'm actually showing you how a Faraday cage significantly reduces the intensity if you must use your Wi-Fi. So the two working together are very powerful because you can kill your Wi-Fi while you sleep. And if you need to turn it on, at least you can know that you're going to be reducing the intensity levels by up to 85, 90%. And this is significant, but just also pay attention that the internet reliability begins to kind of come into question as soon as you start going up floors and as soon as you start getting, 20 plus feet away from the actual router source. So I kind of wanted to just quickly show you guys how easy it is to really assemble this particular router guard here that I've been showing you in this video. Now, if you stay tuned to the end, I'll give you a little bit more details on the manufacturer and what you can do if you're actually interested in buying one of these. And I'll also include some information down in the description of this video. There are some links that you can go to if you're interested in buying one. Now you'll notice that this unit here, it's only two pieces. It's actually a very, very simple install here. And you can see you've got the cage shown here on the right, and there's an actual base shown here in the middle. Now, if you look at the back of my router here, just shown on the left, you'll see there's actually a number of cables coming out the back of it. And this is really what this slot is for here, that's shown here on this base. So really what you do is you just make sure all the cables are plugged into the back of your router. And when you're complete, all you do is just pick your router up and just drop it into the base and make sure all the cables get fitted into that slot. And I'll kind of show you here what the finished result looks like. So here's a shot just kind of showing you the front view of the router sitting into the base. And there's a shot of the back where all the cables are coming out of the back of the router and they just get fitted into that slot. That's really all there is to it. And then the last thing we're going to do is we're going to take this cage that's shown here on the right and we're just going to drop it over top of the base. You'll see it actually fits very, very nicely right into that base. And that's it. And this unit here is actually so simple to install compared to some of the other units that I've tested. And this is one of the reasons why one of the biggest reasons actually why I'm recommending this particular unit, especially with some of the clients that I have out there, that the assembly needs to be simple, and it really couldn't get any simpler than this. Now I just want to kind of do one more quick test for you guys. As you can see, I got my router inside the router guard. But now I have the router plugged into the timer that we talked about in the previous video. Now I still recommend that you guys use this timer. As you can see from all the testing that we did, this router guard doesn't eliminate the wireless radiation. I mean, obviously we still need some of it to connect to our, to connect our phones and all the other gadgets that we use. But it's still important, I think, to make sure that we power down this router at nighttime, just to ensure that this wireless 100% turns off. So this is what I'm just going to kind of show you here right now. As you can see to the right of the router guard, I got my EMF meter, and my EMF meter is running, and I do have the wireless turned on this router. So I'm just going to kind of zoom in and see what we're measuring here right now. As you can see, it's kind of jumping around here a little bit. I've got the meter, it's only about 2 feet away from the router, so the intensity is going to be obviously much higher when you're this close to it. But you can see it's jumping around from about 1.6, it's kind of steady around 1.6 milliwatts per meter squared. That's kind of what we're getting right now. So what I'm going to do right now is I'm going to go ahead and activate this timer so that this router turns off. And we're going to see what my meter does when this happens. Now, if you remember from the previous video, you can see that all these switches here around the outer perimeter of the timer, when they are pulled outwards, this is actually when the electricity shuts off. And when they're pushed inwards, as you can see right here, and you notice I've got the time pointed to the section here where the switches are pushed in, this means the electricity is turned on. So if I want to activate this switch, all I need to do is just kind of turn this dial until it gets to the section here where all the switches are pulled out. So I'm going to go ahead and do that now, and you'll notice as I do that, you'll probably hear a little bit of a clicking noise. So there we have it. We heard a little clicking noise, so that means the timer has turned the electricity off. And now we're going to go back to my meter here and we're going to see what my meter is reading. Now before I do that, I'm just going to show you the front of the router here. You can see all the lights are now turned off. This means the router has actually turned off. Now I'm just going to go ahead and zoom into the front of my meter here so you can see. It actually went directly down to 0. We can assure that the rest of the house is not going to be exposed to any of this Wi-Fi radiation, and I've ensured that I have no other wireless devices on inside my house. Even my cell phones, everything, they're all turned off. So yeah, I just wanted to kind of show you guys that putting a timer in place like this will just ensure that that router shuts off at nighttime so you can have a nice, safe and sound sleep. And I think that's so important. So yeah, I hope this video was helpful, and I thank you guys for watching.